Hello everyone, I want to talk about data frames and how to read data into R in this lecture. Let's use an example to learn these two concepts. Use fitness app data CSV.csv file as the source data and analyze how a fitness app user's yearly incomes influence how long she will use the fitness app. When we perform this analysis, we want to use linear regression model. Let me show you how to perform this analysis in the R software. First, please log on eCollege and go to week 1. Once you open week 1, go to item number 4. Click Example Dataset Fitness App Data CSV.csv. Please be sure to open this file in Firefox because we want the web browser to give us an option to let us decide do we want to open the file directly from the web browser or save the file onto our computer. In our analysis, we always want to save the source file into the working directory. If you haven't set up the working directory, please follow the developer guide in week 1 to set up the working directory. When you download the dataset, you always want to remember the file name. A rule of thumb is to write down this file name on a paper. Because R is a command line software, we have to type in the file name. So writing down the file name on a paper is very helpful for us to remember the source file name. In our case, the source file name is fitness app data csv.csv, and then click Save File. Choose Save File option, and then click OK. And then the source file will be downloaded into your working directory. After we download the source file into the working directory, let's open the R software. This is what I want to do. I want to type in a comment and then I will explain the meaning of this comment. I want to type in simple fit less than small dash read.table parentheses. And then in the read.table function, I want to type in 2 double quotes and then fitness app data csv.csv. This is the source file name. Please be sure the name is as same as the one you just write down on the paper. And then a comma, and then SEP equals to 2 double quotes, and then a comma, another comma, and then type in header equals to T. Now let me explain what I just did. First, please pay attention to the less than sign and the small dash in the middle. Do you still remember we learned this collection of symbols in the variable lecture? What does this mean? Some classmates may say, I want to give the value on the right to the variable on the left. Is this correct? Yes, it is. This is exactly what I just did. I want to create a variable called a simple fit. This is the variable. And then on the right, I want to use the read.table function to read the source data. And then after I got the collection of data, I want to treat them as a value and then give this value to the variable simple fit. Some classmates may have 2 questions at this moment. The first question is, do I have to use simple fit as the variable name necessarily? The answer is no. You can use other variable names as long as they follow the rules we discussed in the variable lecture. For instance, you can change simple fit to my data, my analysis, and so on. The second question is, after I type in this comment, pressed the enter button on my keyboard. I didn't see anything. Is this normal? This is not only normal, but it is also very good. If you see some message show up in the R software, that means your comment is not correct. If you didn't see anything, that means the comment we just type in is correct. How can I say what has been given to the simple fit variable? I use the head function. I want to type in head, parentheses. Between parentheses, type in simple fit, and then press enter. Some classmates may say, this is a data table, right? It is a data table. This is what we got from the source data table by using the read.table function. Now we give this data table to the variable simple fit. So if you use head function, you can see the table structure, what are the data values inside of this data table. But in R, we call this data table a data frame. Now you get the definition of a data frame. It is a copy of the source data table. Each column inside of a data frame is called a vector. How many vectors do we have in our data frame? We have 3 vectors. They are ID vector, incomes vector, and hours vector. Some classmates may have a question about 1, 2, 3, 4, 5, 6 in the first column. Are they a vector? They are not a vector inside of our data frame. The numbers in the first column are given by the R software automatically, but this is not a vector of our data frame. In our data frame, we only have a ID vector, incomes vector, and hours vector. As we just discussed, a data frame is a copy of the original data table. That means if we make any change in the data frame in the R software, the change will not influence the data stored in the source file. Why do we want to have a data frame? Suppose we made some mistake inside of a data frame in the R software. We can always use the read.table function to restore the original data table. This is very important to data analysts. Each column in a data frame is called a vector. What are the key features of vectors? How can we access to vectors stored in a data frame? Let's see some example. If you want to access to a vector in a data frame, you use a $sign. This example shows everybody how we can access to the incomes vector stored in the simple fit data frame. We use a $sign. First, we type in the data frame name, simple fit, and then we type in a $sign, and then we type in the vector name. By doing this, we can access to the elements stored in the incomes vector. What are the key features of vectors? The first key feature is, if we make a change on a vector, every element stored in the vector will change in the same way. Let's say we want to increase every user's yearly incomes 10 times. We use this statement. Let's try this in the R software. In the current data frame, the first customer's yearly income is 100,000. The second one is 50,000, and so on and so forth. We want to increase these numbers by 10 times. So we type in 10, an asterisk. In R, an asterisk represents a multiplication. And then the data frame name, simple fit. We must use the same letters, same cases as when we create this variable. So if you type in lowercase f, then the R software will give you an error message. We must make sure that f is in uppercase. Next, we want to type in the $sign. The function of this $sign is to access to a vector in a data frame. The vector we want to access to is incomes. So we type in incomes. Make sure I is in uppercase, as same as the vector name in the data frame. And then press enter. Now you can see we multiply each number by 10. What if I want to add a new vector into a data frame? What should I do? First, we use the C command to create a new vector, and then we add it into the data frame. This slide showed everyone an example. Suppose we want to add a new vector called age in the simple fit data frame. We already got the customer's ages. We use the C command to organize these ages into a new vector, and then we give this value to the new vector called age in the simple fit data frame. Notice that we use commas to separate these numbers in the C command. Let's try this in the R software. In the current data frame, we only have ID, incomes, and hours, 3 vectors. We don't have a vector called age. This is what we want to do. First, let's type in the data frame name, simple fit, and then add a $sign. After the $sign, you want to give a name to this new vector. In our case, we want to call it age. Some classmates may want to use different vector name, such as user age. Can I do that? Yes, I can. I can use any name as long as this name follows the rules for creating a valid variable in the R software. Let's call this age. Next, we want to use a less than sign and the small dash. We want to give a new value to this new vector. Since there are a lot of numbers, I will not type it in one by one. I just go back to the PowerPoint and copy from the C function to the end. Let's make a copy. And then let's go back and then paste. By the way, if you are using a Windows PC, the shortcut for copy and paste is, if you want to make a copy, press the Control key and the C key on your keyboard together. This will make a copy. If you want to paste the data into the software, please press the Control key and the V key on your keyboard together. Press the Control key and the V key at the same time, and then you can paste the data set into the R software. Press Enter on the keyboard. We didn't see anything, right? That means our command is correct. But how can I see the new data frame? We still use which function? The head function. Type in head and then parentheses. And then type in the data frame name, simple fit. Press enter. Now you can see, besides the 3 existing vectors, we have a new vector called age. This is how you add a new vector into a data frame. Some classmates may say, now I know how I can add a new vector. How can I delete a vector? This is a very good question. We use the null value. This is what we do. First, choose the vector you want to delete. Let's say we want to delete the age vector. Next, type in the data frame name, simple fit. How can we access to the age vector? We must type in a $sign after the data frame name, right? Next, you want to type in the name for the vector you want to delete from the data frame. We want to delete age, right? So type in age. Make sure A is in uppercase. The vector name is as same as the one in the data frame. Next, we want to type in a less than sign and then a small dash. That means we want to give a new value to this vector, right? What value do we want to give? we want to type in null, null. Null means empty. That means you want to empty the vector h in the data frame. Let's press enter and take a look. We didn't see anything, that means our comment is correct. Let's use the head function to take a look at the new vector. Head and then simple fit. Press enter, you can see the h vector is gone. This is how you add a new vector and delete vector in a data frame. Now we can perform the linear regression analysis. Later in this semester, we will have a particular lecture for linear regression analysis. In this lecture, I just want to give everyone an overview about this analysis. How we can perform linear regression in the R software. The common name in the R software for linear regression is LM. LM represents linear model. When we perform the linear regression analysis, we must use the common name LM. Please remember this. This is what I want to do. When I perform the analysis, I want to give the analysis result to a variable as well. So before I type in LM function name, I want to create a variable to hold the analysis result. Let's create a variable called simple analysis. Remember, this variable will hold the analysis result from the linear model, and then a less than sign, and then a small dash. We are very familiar to this collection of symbols already, right? We want to give a value to this variable. In our case, the value should be the results from the linear regression model. So let's type in LM. The LM function has two parameters. The first one is the regression model. The second one is the source data. Let me type them in and then I will explain the meaning of them. I want to type in hours and then a tilde sign and then incomes and then a comma. Next, I want to indicate the source data. I want to type in data equals to simple fit. Let's talk about them. First, we want to build the regression model. In a regression model, you want to indicate what is the dependent variable, what are the independent variables. In our case, we want to analyze how a user's yearly incomes influence how long the user will be using the mobile app. So the dependent variable should be how long the user will use the mobile app. In our data frame, all the data about the length of usage are recorded under hours vector. So we want to choose hours as the dependent variable. And then we want to type in a tilde sign. The tilde sign is in the top left corner of your keyboard, under the ESC key. After the tilde sign, you want to tell the model what are the independent variables. In our case, we want to use the user's yearly incomes as independent variable. Where are those numbers recorded in the data frame? They are under the incomes vector, right? So after the tilde sign, we want to type in incomes. Some classmates may say, what if I have two independent variables, both incomes and age? How can I build that model? This is what you do. After incomes, type in a plus sign and then type in age. That means you want to use incomes and age as two independent variables to explain how long the user will be using the mobile app. If you have one more independent variable, you just type in another plus sign and then type in the variable vector name. This is how you build a multiple regression model. In our case, we only have the user's yearly incomes. So let's use incomes as the only independent variable. The second parameter of the LM function is the source data. Please remember we want to use data equals to. After the equal sign, we want to indicate where do we get the source data? In our case, we already built the data frame. We store this data frame in the variable called the simple fit, right? So after the equal sign, we type in simple fit. Next, we want to press the Enter button on the keyboard. We got the data analysis result. How can we see those results? We need to use a new function called a summary. Let's type in summary, parentheses. Between the parentheses, you want to type in the variable that holds the data analysis results. We saved the result into a variable called simple analysis. So let's type it in, simple analysis, and then press Enter. Now you can see the linear regression analysis results. In the regression lecture, I will explain the meaning of these results. In this lecture, I want you to focus on the data frame concept, vector concept, how to add and remove a vector in a data frame, and how to use the array.table to import data into the R software. After today's lecture, I listed some exercises on eCollege. Please use the knowledge you learned from this lecture to do those practices. This concludes today's lecture. I'll see you soon in the next one.